Thank you very much, Lance, and welcome everybody. We're quite excited to be here with you this morning to share with you our experience of dealing with operators and service providers who have current SDH networks and are looking for the way forwards, and those who have already started down that track. And to help us do that, I have two of my esteemed colleagues, Mr. Tony Torley, who has actually been out there talking to you guys and your colleagues in the operator space and understanding what their issues with SDH networks are and what they can do. And he will share some of that knowledge with you as we move forwards. But as we're talking about going to packet migration, we've also got our packet expert or our IP transport expert, Elias Igali, who will tell you why IP transport is now ready to do SDH and what some of the things that can be done to make that transition easier or more reliable. But before we move on that, it's worth capturing why we as Ribbon have this experience. I mean, we've been around in an ECI, guys, for over 50 years, deploying the sort of networks out there, which, you know, initially PDH, then SDH for 20, 30 years. So we really understand those SDH networks throughout the world. And now we also understand with our IP MPLS and our optical solutions, how we migrate those onto an IP MPLS solution. So we have great experience on what SDH is and what it does for you, and then how we migrate that. So moving with that, it's got to be acknowledged that SDH has been hugely successful over the 20, 30 years of its lifetime, and we've learned a huge amount from it. But as you're all aware, we've now reached a point where the supply of the SDH networks or the components is reaching end of life. Unfortunately, we do have the IP technology which can deliver equal or better performance. However, from our experience in talking to service providers, migrating these legacy SDH services onto these new technologies isn't just a technology thing. It can prove to be extremely complicated. And we'll discuss this as we move forward with our distinguished panelists. So to start on that, I think we really need to understand what SDH is, what it did for us, and why it's was important in moving telecoms forward. Then we can look at what issues there might be when looking forward for migrating SDH to IP. So Tony, would you like to just give us a brief overview of what our SDH taught us and what some of the issues might be?
Okay, yes please. So SDH has been around for a while. I do remember the time before SDH when the transport services were fine, PDH up to 140 megabits a second, even 565 megabits a second, but there was a number of issues with those. There was little service visibility, so you couldn't tell when you were delivering a service whether or not it was being delivered successfully until your customer called you and said, I don't have a service. Resilience was available, but it was separate boxes, so it was a multi-box solution to get any resilience into the transport network. The interfaces and the speeds were not standardized fully, so you couldn't work one 140 megabit system into another 140 megabit system because people would use different codings. So all of those were issues. Then come the 1990s, the revolution in microchips, particularly application-specific integrated circuits, allowed us to put more processing into the platforms. And that allowed SDH to arise. So the standards for SDH included comprehensive service monitoring. So the ability for every single service you deliver to have a path overhead and to tell you whether or not you were getting errors on the service you were delivering. Service protection and network resilience, so you then had some network connection protection, multi-section protection, ring-based protection mechanisms, card protection built into the standards. So you can now build networks which are automatically recovering from faults, increasing the availability and reliability. Timing. PDH networks sent timing as a PDH signal. SDH networks started to put this on a more formal basis with resilient timing. So timing distribution from first level clocks spread out across the network with multiple routes. So if one route failed, timing would still be recovered. And interworking. SDH being a set of standards allowed the SDH interfaces to interwork, so you could get mid-span meet, or you could run different SDH vendors on the same network. One of the issues at the time with PDH was what was called the multiplex mountain, where you had to multiplex 2 megabits to 8, 8 to 34, 34 to 140, and then when you wanted to get a 2 megabits out, you had to demultiplex it all. To an extent, it was the application-specific integrated circuits that resolved that, because they introduced far more processing in there, but SDH integrated all the multiplexing with the transport into the same platform. So that was the 1990s, and they were mainly for voice and some low-rate data services, E1 services, 34, 140 megabits, 45 megabit data services. Ethernet continued to grow as a wide area network requirement, and SDH introduced in the 2000s, 2006-ish, a number of standards to map data efficiently into SDH. So generic frame protocol, virtual concatenation, and link capacity adjustment scheme all allowed us to put containers together to make bigger containers, to adjust them in flight, and to carry data in a more efficient manner. The picture of the flag waving is just to indicate none of the old standards ever disappear. X25 is still with us, frame relay is still with us, ATM is still with us. It will be a long time before SDH leaves. We even like bonfires for occasionally now. Next slide, please, David. So what SDH users have grown accustomed to are these types of capabilities. Hard service separation. Doesn't matter what happens to the network on other people's services, they don't affect your service. Hard performance guarantees, accurate timing, excellent OEM, all the things that make the service reliable and available and can be monitored. It is relatively easy to design, deploy and manage. It is ultimately just plumbing with a few bits added on. You're setting capacities, and then when you plug it all together, it generally works. E1s and T1s are still widely used. A lot of voice services are still out there. A lot of critical infrastructure still uses those sub-E1 services, the V24 standards, V35, FXO, FXS, E&M, C3794, to carry critical message across the network. So they're still out there. SDH is well understood. There's a lot of people who understand it and are reluctant to change. Okay, next one please, David. So what could possibly go wrong? Well, in essence, SDH networks have grown over the past 30 years. What started out as a well-planned network now tends to be less well-planned. Companies merge. In some cases, lots of companies merge together. So the SDH networks are not fully documented. The connectivity is not fully understood. Whether all the services are live or not is not fully understood. Are they all being used? Does the customer know they're paying for a service? So all of these things leave networks a little bit in the dark as to what's going on. SDH also carries a whole load of other things than services. It carries internal traffic for operators. It carries the timing for networks. So many other networks, many data networks carry timing on the SDH layer. It carries a lot of the management systems. So many networks carry the management over the SDH layer. All of these will need to be replaced if you want to remove the SDH network. So you don't really know what's out there. It's carrying a lot of stuff that's very useful. Migration can be complex. Apart from anything else, change triggers customers to shop around. So it's not trivial to change from an SDH network out. So that's my first bit sorted, David, setting the challenge.
Okay, so I mean, focusing just on the technology area for now, Elia, given the list of transport requirements that Tony outlined for SDH, what sort of IP transport or packet transport technologies now exist to aid in replacing these SDH networks?
Well, David, the solution is already out there, and it's already in networks, and it's already proven. And I remember in my career, I configured my first SATOP on MPLS in 2007, and that was carrying 2G mobile backhaul and eventually also 3G. So the solution is already out there. So it's not something new, something to get scared of. It's already proven. And these RFCs here on the slide, they exist already over a decade. So for example, for E1 and E3 bit streams, you got the SATOP. for the lower bit rates, you got the SASOP, and for the SDH STM stream, you have the circuit emulation over packet, and this one is readily available. You can buy them from us, for example, as a solution. And aside from that, Tony had mentioned about timing. IP networks have various timing distribution capabilities. You can do adaptive timing. You can do SYNC-E, the IEEE 1588, for example, that is being used for 5G networks. IP networks can deliver that. And the thing with reliability and availability, IP networks also have that. You can have network protection schemes in IP networks, and it can do sub 50 milliseconds, which is the mecca of all switching time. The SDH standard 50 milliseconds switching time is also available in IP networks, and even better. And if you want to have the same hardware protection schemes, you have the same protection schemes that you enjoy in SDH networks. It's also available in IP platforms nowadays. Next slide. And looking forward, we can take it even to the next level with this smart circuit emulation services, SFP. It's like a circuit emulation service card in a pluggable. So you can plug this in any Neptune IP platform, and it's very suitable for low port fan out use case where you have a lot of IP services and you are migrating only a few E1s, for example, and you're saving power and you're constrained in space, and this is very ideal for that. And you can interrupt this with the CES card on a Neptune, for example, our IP platform in Ribbon. So on the other side you have the pluggable in an IP platform, and on the other side you have an IP platform that aggregates all the E1s, for example, and you terminate it on a CES card for higher density. And then you have end-to-end management that you always have been enjoying with SDH networks. You can do that as well with IP network delivering the SDH service. Next slide, please. So the world has moved to IP, okay, and IP has evolved. My younger years in the industry, IP was snubbed by the SDH guys because it's previously it was very clunky. It's like the post office. You send a mail and you pray that it will get to the destination. It's connectionless. So just send and pray that it will be delivered. But the world has moved on. So you can trust the IP network because IP networks can deliver services with the same low latency, the same low packet loss, and predictable jitter that you are accustomed to with SDH networks. And you can do this by very good QoS designs that will prevent congestion, bidirectional paths that you always have with SDH. And you can also have new traffic engineering schemes so that you can manage your resources and optimize your sources. Talking about OAM as well, you have it in IP networks. So you have OAM, performance monitoring, and telemetry, which is something new. And you have network architecture redundancy and protection. And you can even control the misbehaving traffic using analytics, because previously IP was clunky because it was dealing with best effort and bursted traffic. But now with new generation IP networks, you can control this by setting thresholds that when it meets a threshold, you need to drop packets that are lower priority than your higher priority SDH services. So you can have this fancy stuff already today. And of course, there are new forwarding techniques that you can choose from. They are scalable, they are simplified. And what is the toppings on your muffin, I would say, the toppings of the IP network is that today you can have this intelligent control and automation, which you did not have in SDH networks. With your programmable network infrastructure, you can be intent-based in your network. You have best effort, you treat it as best effort, and if you have SDH and it's critical mission, you treat it with higher priority, and the network knows this. So there is some kind of intelligence in your network, and you have this today. You can be traffic aware, resource aware, you know exactly which resource to give to your higher priority traffic and which resource you give to your lower priority traffic. And what is very important is that it is multi-layer. So SDH is looking at a certain layer. But if you have this intelligent control and automation, you can see your IP layer and you can see your optical layer, and you can make sure that the logical connection, which is from A to B, doesn't go the ring on your optical network in the underlay twice, because your automation and orchestration system sees this and makes sure that the latency is maintained and it does the shortest path from A to B. Next. So just giving an example of the a use case here. This is a use case of the old world meets the new world. So it's a use case for voice application where the operator has a new generation SRv6 IP network in the middle, and they wanted to migrate the SDH services from their SDH network to this network because it's end of life. They cannot anymore purchase the spares and so on, and it needs to be migrated. So what we are doing is that we put Neptune, we have this IP platform, as a circuit emulation service overlay over this SRv6 network, and we have we can use, for example, smart SFP for those low E1 counts sites, and for the high E1 count sites you can have the SAS card. So it's a combination, and with this solution the jitter and latency of the SDH service is being maintained. That's because in the Neptune we have this jitter compensation that compensates the jitter, and it is maintained. So the service is the same service that you have on your SDH network, but the difference is now it is in the new network, and then you can decommission the old network and you can get rid of your network, get rid of the legacy stuff, and you can move on to the new world. Next.
You're on mute, David.
So it's great to hear that the IP technology has moved past send and pray and now can meet these requirements. It can absolutely do everything that SDH did, and in some cases can be better. And that's what I'm hearing from Elia. So from a technology perspective, I think packet transport, IP transport is there and ready. What are some of the other advantages, Tony, of moving towards an IP transport type network?
Okay, right, thank you. Well, certainly if we look at the picture on the right of the screen with the original SDH elements, which were sort of one rack size for an STM32 add-drop multiplexer, there are massive space and power savings available by moving to more modern technology. So replacing old SDH will clear huge amounts of space and save lots of power. So from 2015, we're down to a 1U device. We have trip cards now that fit into these, and what Elio was talking about with the smart SFPs, we now have SFPs which can do E1s, STM4s, STM16s even, all the way down to those. So technology has provided us with the opportunity to save lots of space and power. I think it's worth saying again, SDH introduced a whole host of new capabilities which customers have found very beneficial. The IP and Ethernet standards have taken these on board. They recognized they needed to do something to make IP and Ethernet a wide area network capable technology, and they've taken on the resilience, the latency, the timing, the operations, administration, maintenance, performance. All of these capabilities now being brought into the packet world. So lots of space and power savings, lots of advantages of moving into the IP world. I think Elio will cover some of the other new services which you can start to add to the network on the next slide.
So Elio, as Tony said, do you have anything to add from a technology or future network perspective? And of course you have, because Tony just alluded to it.
So
what's going on, yes.
say for example you have moved on as well. So you have moved your SDH services to a new generation IP platform, so you can enjoy other things, other services, or sell other services if you're an operator, service provider. There are other services you can now offer, like on the same platform you can offer 4G, 5G mobile backhaul, you can do broadband backhaul, you can support MEC, multi-edge access, edge, traffic on the same platform. You can offer IP wholesale services, and the traditional IP services, MEF services, for example. There are 2 VPNs, there are 3 VPNs, and on top of that, you can offer now business and mission critical networking in the same platform together with your SDH, because if you can prioritize this and guarantee the service of mission critical services, then you can offer these services, not only SDH services over IP, but you can also provide IP services, Ethernet-based services with the SDH-like guarantees on the same platform. Isn't that nice?
Yeah. So given space, savings of space, power, size, throughput, multi-service, why are customers still buying SDH, Tony? And why might this actually be creating a longer term problem for them?
Okay. I think we've got another slide coming up. So the reasons that I find that I'm still designing SDH networks for our customers is they have to patch or extend an existing network. So the network is SDH. There's more services being added to it, voice services in some cases, or they want to interconnect bits of the network together, and they don't want to change an entire network just to add a little bit on. Sometimes their customers insist on SDH. They've grown up with the reliability of SDH. They associate SDH not with a transport technology, but with a level of quality of service. And so they say they want SDH because they want that quality. They don't really know why SDH delivers it, but they've done it in the past. Often they understand and trust SDH, so they're in a position to build new SDH networks, but they're not really in a position to deploy a data network of the same capabilities because that's a new set of skills. But as it says there, SDH is coming to an end. As the graph shows, the level of spending on equipment in SDH, certainly up to 2018, had significantly fallen, and it's just gone smaller. There is no longer sufficient business to justify the development of new equipment. There's even not enough business to justify the manufacture of the chips to support the SDH. So it's coming to an end. We have to stop manufacturing SDH. We have stopped manufacturing SDH in many cases. And shouldn't operators be investing in technology with a future? If you are building new network now, it would be nice to think it had a 15 or 20-year lifetime, not being built out of something which is already end of life and even coming to end of maintenance. So although people are still buying SDH, they need to seriously think about, is this not just an investment in something which has a very limited lifetime capability? I think there's another slide, isn't there? Options.
There is, yeah. So just to follow up on that, clearly it makes a lot of sense to move off SDH and migrate to IP transport. From what you said earlier, it's very difficult and complex situation that you're trying to solve. So in your discussions with customers, what have they been doing, or what are their potential migration approaches you've been talking over with them as they look to migrate these things? So what sort of options are you seeing, Tony?
Okay. Yeah. So, two-part slide. The first part, options. Certainly convert the TDM services devices to IP. As Elia has explained, there's all the technology there, there's all the standards, it's been around a long time. IP equipment is perfectly capable of emulating TDM services where you need to emulate them, or taking the services, moving them to IP and giving the same quality and resilience that SDH gave them. Certainly that's a possibility, and that exists, and we've been doing that regularly with customers. For the high-speed services, STM1s, 4s, 16s, STM64s, you can carry them directly over the OTN network, G709 standards, on wavelengths or directly on OTN. However, the reality, there are space and power savings, but they are not enough to justify the costs of the engineering effort required to migrate the services. If I'm going to migrate all my E1 services, which could be thousands of them, I need to plan that. A lot of engineering resource into planning them. Particularly if you don't know really what your SDH network is doing, or where all the services are, or which customers are connected and which aren't, it takes a long time to work that out. The customers have to be informed there's going to be service outages, because you've already agreed that in their contract, that there won't be a service outage without telling them. Your data services will be lower margin, so you're going to lose money by moving customers to data services. And any customer who's faced with a change can look at that and go, oh, maybe I should try looking around and see when I've got a better deal elsewhere. So there's a lot of reasons why migrating services is very expensive, and why the savings you'll make are insufficient to justify the migration. But you've also got to remember that running an SDH network, whilst it's end of life, when it's end of maintenance, risks failure. There are problems coming, and you've got to look at those as well. So I think the next slide is, where do we go from here?
Yes, so I was going to ask Elia that question. Now, given this huge complexity of doing a mass migration, and operators quite rightly being worried about doing a huge step and setting a huge project up, are there any other approaches as opposed to mass migration day one? I'm just thinking, for example, of the Chinese proverb, a journey of a thousand miles starts with the first step. Elia, what do you think the approach is opposed to mass migration might be? Or is it the only option?
I think Tony can best answer that, Tony.
Sorry.
I'll do this, yes. Migration costs are high. We just covered that. They are high, so if you can, don't add new services to old SDH networks, and don't build more SDH, please. Just think of it as something you've got. Don't make the problem worse. You're digging a hole, stop digging. That's the first thing. Or somebody once said, if you're digging a hole, take some fiber with you and bury it. Build new IP networks with circuit emulation capabilities, or add circuit emulation to your existing IP and packet networks. So use that. Leverage proven switch network technologies like label switching to deliver SDH services together with IP services. So your IP, your packet network, can carry multiple services. Use it to carry the TDM services you need. That doesn't solve your existing issues. There are some services on your SDH network which are either sensitive or critical. Things like the blue light services, police, fire, ambulance. If your SDH network failed and those services failed, lives are at risk. You need to think about migrating those to a network which is current and supported and has a life expectancy in front of it. There are other services which, if you lose them, could be embarrassing. And I know examples. One example I have is some sporting fixtures carried over a network. The network failed. There were millions of people who blamed the operator for losing their, in this case, cricket. The recent example might be football. Imagine carrying the football on your network to a broadcaster, to a broadcasting state, to an antenna, and losing it. It would be embarrassing. So, services which are serious risk of life and critical, or services which are sensitive, business services to banks, those are the crucial services where you risk reputational damage, or fines, or litigation, or regulatory penalties. Those are the services you need to seriously think about migrating from the SDH network to the IP network, irrespective of the cost. All the other services you may be able to do slowly but surely, let them die, put the prices up, but the critical services, the sensitive services, are ones you should seriously consider getting off your SDH network now before it fails, so you don't suffer the penalties and the disasters that would come if it does fail. So that's the suggestion I have. I'll let Elia look at this one.
There you go. So who's clunky now? So I mentioned before, IP used to be clunky, but as you can see, if you have an old car, it will be clunky after some time. So one benefit, immediate benefit when you migrate from SDH to IP is that you reduce the risk that Tony thoroughly here just mentioned, and the cost of having a legacy network. And yeah, I have spoken about the car as an analogy. They say that vintage cars last forever. Yeah, but then it doesn't have power steering, does it? So, yeah, when you have an old stuff in your network, it will not have the new stuff and the future service. It will not carry new services. So when you migrate, you have all this nice stuff that I had just mentioned. You can have automation and orchestration. You can have a multi-service platform. And you can introduce high capacity services. We can even go as high as 100 gig in service in the access, for example. You can deliver that in the IP network. And you can do network engineering schemes that can optimize your network very well. And yeah, network support for new services like 5G, for example. And best of all, where the money is, you can optimize the use of your network resources. So you can do hard QoS for the predictable performance of your SDH services. And together with that, you can do statistical multiplexing for your best effort services in just one network infrastructure. So
thank you, Elliot. Thank you, Elia. I mean, I'll just summarize what I've heard from Elia and Tony, and then we'll move on to what I think is an important part of this webinar, is to try and have some open dialogue with you guys. So feel free to answer the questions in the question box, and you can use access the expertise that you've got from Tony and Elia in this space. But just to summarize, so I think the first message, really quite clear, is you need to stop investing in putting new SDH out there. It's just causing a long-term problem for you, which you're going to have to fix in the future at some point anyway. So stop investing in building new SDH when there's a perfectly good, if not better, technology out there to replace it. And then the reasons for that are here. I'm not going to read through them. We at Ribbon with our expertise in SDH over multiple decades and in IP/MPLS over a couple of decades, we really do have the expertise and capabilities to support that transformation, whether that be SDH to IP transport, as we're talking today for the lower rate services, or SDH over OTN if you're talking about much higher rate services. Sometimes it makes much more sense to go straight to the OTN layer, or a mix. So you want something that can be seamlessly IP or optical, and you choose the right solution for your needs. And we have the expertise in SDH IP optical to make that right for you and tailor it to the way you want to run your network and move your network going forward. We've also field proven this migration. We're very, very strong in the critical infrastructure space, where we've migrated SDH networks in mission critical applications and proven that they will work and continue to work. And these critical infrastructure guys are very, very happy with IP transport as a replacement and our mechanisms for moving them. So I think both is important. The technology's got to work, but you've got to be confident that we have the processes to support your business needs as you move forward. And we've taken that and rolled it out to service providers as well. So you can get the service providers we talk to around this space. They know that we have the confidence and the ability to move their networks, and they're confident in that. So in short, going back to my statement earlier, a journey of 1,000 miles starts with the first step. It really is time to take that first step. So now is the time to tackle that legacy SDH network, move to IP, and our recommendation is a good starting point is move those sensitive mission critical services first as a priority, because they're the ones that are going to cause you a massive headache if they go wrong, and then use that to build your experience as you start to migrate other parts of your network. And one thing to mention just as part of that point, the SDH networks themselves have been in the field for 10, 20, 30 years in some cases. Whilst they've been extremely reliable and hassle-free, they are now reaching the end of their reliability bathtub. I think we all know this, the reliability curve. You know, the bathtub, the failures at the start, really flat, no failures, no failures, no failures. We're starting to see the upswing of network failures. So whilst you think they're no trouble for you today, as those failures get greater and greater and greater, they're going to start to become a management and a reputational headache. So start dealing with the issue now. So thank you very much for that. Now we'll move on to the Q&A, and we already have, I can see 3 or 4 questions that have come in. So I'll start with those, but please ask some more questions if you really want to know more about this on the open forum. We're here to answer your questions. So I think this one's for Tony, looking at the question. You mentioned, Tony, that SDH is becoming end of life. Do you want to explain why that might be, or what's creating that? I think you had that curve of the stuff, but you want to go into a bit more detail on that?
Yeah, there's plenty of reasons why SDH ended up. It has been around there now for 30 years, and it was brilliant. It was brought in to be a more efficient means of carrying voice-based services around the network, and it worked fantastically. It's brought a whole lot of new concepts to network transport, which have been taken up by the data world, the packet world, the IP and the Ethernet world, and built on to get even better. However, SDH were designed around the VC12s, the 2 megabit payloads, and traffic has continued to grow, and it's no longer appropriate to have such small payloads in transport networks. Normally you're looking at much faster now. I mean, if your home broadband is getting up towards 50 to 100 megabits a second, then you do need to be carrying those sort of volumes of traffic even in the access network. So SDH, wonderful for voice, worked well in the initial packet phases when packet and data services were low, and we brought in GFP and LCAS and VCAT to do that. But it's now been overtaken by events and the exponential increase in traffic on the network. SDH is over-engineered to carry that, and it doesn't have the latest capabilities. So the volume of SDH equipment being sold has dropped considerably, as the graph I showed earlier was pointing out, and it makes it uneconomic for chip manufacturers to manufacture chips when they can be manufacturing chips which are being bought in far higher volumes. and it's therefore uneconomic and impossible for vendors such as ourselves and others to continue to buy these. We have to buy a huge stock at our risk. And our customers are no longer buying anywhere near as much SDH. I still get inquiries for SDH networks, but they tend to be very small and specific to niche areas, and it isn't a business case that we can continue to support. So SDH is going end of life because of the economics of the technology and because of the rise in the huge requirement for new data services.
Okay, thank you for that. A second question I've got, which is an interesting one, I think, is it alludes to the fact that this what we're talking about today isn't really, or isn't just a technological issue. It's more or as much about a project management process issue, and it's all around the migration. So, Elia, who would do this migration? How, in your experience, how is that migration likely to occur?
Well, one thing is that we can handle your migration based on our many years of SDH experience. That means we understand SDH and how SDH services should be treated and prioritized in the network. So that is very important. When you are migrating, you make sure that on the network you are migrating, you are maintaining the strict network requirements that it used to have in the old SDH network. And we can do that. On top of that, we have the full suite of IP capabilities in our Neptune platform to deliver not only SDH services, but also other new services over IP network.
Okay, that I think that answers the question. And I can see another one come in here. Again, this is probably about the migration process, but but it's more about the interim phases, because you don't start, I think, from SDH and suddenly you're IP. You're going to have a long period of time where you're both. So the question's asking, how does that work? How does it work when you have SDH in the network and IP transport in the network? Doesn't that become an operational nightmare? And Tony, do you want to take that one, because you've talked to the customers and seen them in this position?
So yes, the more modern elements that we're selling can be run from a controller, an orchestration layer, SDN controlled. They can be run from a network management system. The SDH elements, the old elements, don't have the capability to be directly controlled by a controller or orchestration SDN capability. Generally what would happen is that the network manager for the SDH layer would stay there. It would be managing the SDH, and the management platform would be able to interwork with the orchestration layer. So in Ribbon, our Lightsoft management platform can be connected directly into the orchestration layer. So it will handle the communication between the more modern orchestration and the older GUI-based management system for SDH. Generally, you won't be doing much reconfiguration of that. You'll be just monitoring it for alarms and performance rather than doing a new build of the SDH. And so by having a management system which interworks with the orchestration layer, you can then also use the same orchestration layer to run all of the new packet and data capabilities in the network.
Okay, and I think this is quite an easy question I've got in, but as ever, anything that's easy tends not to be, or maybe it is. So the question here is, with all this overhead and stuff you're throwing on top of the sort of packet network to handle SDH, doesn't the packet network take up far more bandwidth than the native SDH network? And I guess, Tony, as you were speaking, you may as well take that one.
Yeah, so our experience is it takes about twice the bandwidth. So an E1 at 2 megabits a second, if you convert that into a circuit emulated E1, you're looking at about 4 megabits worth of packets across the packet network, which sounds like it's double the cost. But the cost of moving bits in a packet network is massively lower than the cost of moving bits in an SDH network. And the capacities of the packet network, the IP network, are so much greater that you barely notice adding any of the SDH. I mean, if I'm carrying 100 or 50 megabits of residential broadband per customer, then that's 25 E1s. Now, previously, when I first started working for an operator, the cost of an E1 service would justify digging up the street and putting some fibre in for a few hundred meters. That's no longer the case. You will not get anything like that amount of money for a 2 megabit data service. If such a 2 megabit data service exists, you're looking at 10 megabits, 100 megabits has been the sort of norm. So yes, use about twice the bandwidth converting a TDM, a PDH or SDH service into a packet service, but the bits in a packet network are much cheaper and there's a lot more of them.
Okay, thank you, Tony. And I've got a question in here from a completely different direction, but I think given current environments is really, really important. By current environments here, I mean every day goes past about, you read something about bits of network or data being hijacked and ransomed and stuff. What's the impact on security of migration to packet? Is it a good thing, a bad thing, neutral?
Well, the best thing in IP network, like I said, you can be traffic aware and you can be intent based. So you can treat the packet as it should be. So if you are worried about confidentiality and integrity, for example, security, the IP network offers different types of encryption. If the data is really that important, you want to secure it, you can do encryption at the MAC layer, MAC encryption. You can do it on the IP layer, or you can even do it on the underlay. You can do it on the optical layer. So nowadays there are many options you can do in your new generation network to be able to secure the data. And not only that, because availability is also security, you can make sure that you have the 5 nines that you used to have, that the data is available all the time and reliable all the time. So you can also do that.
So just to follow up on that, so from what I'm hearing, Elia, the ability to now add all these various forms of encryption and isolation and security, that's another reason for migrating your critical services. Or is that another reason for migrating your critical services to packet, because you've got more control of the security? Is that a true statement?
Yeah, certainly. Some business services nowadays require that there's some kind of certification, like here in Germany, there is some kind of standard certification that agencies should be comply to, and they are required to do encryption on this mission critical or business critical services, and that you can't have with your SDH network, the type of encryption that the industry nowadays require. So
okay, that's interesting, because that's another reason to focus on those critical services and migrate those as soon as possible, rather than take the risk of staying on SDH with those, or certainly build new SDH for them. Okay, I think this question came up when I mentioned OTN and WDM or something, Tony, but it's probably you have more detail around this. What role does the optical layer play in SDH migration?
So if you're trying to migrate some of the bigger services, STM1s, 4s and 16s or 64s, you can circuit emulate them. I think you can circuit emulate up to STM16. But the alternative is to use the OTN G709 standard, which was designed partially to carry many of the SDH capabilities. So STM16 can be mapped into an ODU1 payload at 2.5 gigabits, and STM64 can be mapped into an ODU 2 payload at 10 gigabits. I'm getting there eventually. STM1 and STM4 map into ODU zeros, which is not very efficient because that's a 1 gigabit per second payload to carry 155 or 622 megabits a second. But once again, the cost of capacity, the cost of bandwidth has come down so much that even though it's less efficient to map these together, it's still probably much cheaper than building an entire SDH network just to carry a few STM1s or STM4s. And in fact, I'm looking right now at a design which is carrying multiple STM1s, STM4s, STM16s and 10 gigabit Ethernet on the same OTN network. and a 100 gig OTN connection, an ODU4, has 80 ODU0s. So it could carry 80 STM1s or STM4s within its capabilities. So you can mix and match the legacy SDH and the data services in the optical layer very efficiently.
Okay, I've just spotted a question I missed from right at the start in your presentation, Tony, right at the very beginning there, so I'm sorry about that. The question is, you mentioned, people with SDH knowledge are retiring. Why is that an issue?
If you continue to run an SDH network, then you have to support it. You have to have people out there who can maintain it and can operate it. You need to maintain the management system. So there's a cost associated with that. But there's also people associated with it. If you have people who don't understand the technology, then the danger is, as we have seen with some of our customers, if they go to a site to try and fix a fault, then they end up making it worse. So it's important that there are people trained to understand the technology. Now, if you're a new engineer joining a company, it may not be your lifetime goal to be put onto a 30-year-old technology to maintain it. Interesting if you're a historian or an archaeologist, but still 30-year-old boxers running protocols which nobody now needs is not maybe the best career choice for a new graduate engineer. So the danger is that you start to lose the experience and the expertise in SDH. You can't recruit new SDH people because they are either deciding to stay with their current job where they know they've got a job for as long as the SDH network is there, or they're moving on to other things and retiring, and they're not interested in looking after SDH boxes anymore. So there's a danger that if you maintain your SDH network, if you build more of it, how are you going to look after it? Who are you going to persuade to provide you with that maintenance and monitoring capability?
Interesting, yeah. It makes a lot of sense that, and particularly as the network's failing, as I said, it's likely to start failing much more regularly. You're actually going to need more SDH experience, not less.
Yes.
So better to have less SDH network to manage, I guess. So yeah. Okay, I think we covered this, but it's worthwhile reiterating. I guess the question is, from your experience, what network services operators that you're talking to are looking to migrate first? I guess Tony, you can both answer this, but maybe Tony start.
There's a desire to move away from SDH, and there's a desire at senior management level in many companies to move away to save the space and power. And then it percolates all the way down to the engineers who look at this and say, yes, you can save space and power, but you're going to pay this enormous cost in designing and moving your circuits away from there. So there is this difficulty which we explored in the slides earlier about you don't save enough money to justify the cost of migrating. But there are important services, and these are services which we talked about, the critical services, the sensitive services, which are important to move first. Critical infrastructure operators now are biting that bullet, and they are regularly, and we are regularly supporting them to move away from SDH into the IP networks, the IP MPLS, even the MPLS TP networks with the dynamic deterministic behavior, so they can retain the deterministic behavior and the resilience that they have from SDH, but move into a set of elements which have got a future to them, not building a new critical infrastructure control network out of something which is already end of life. Because when you're looking at power networks, at oil pipelines, at water networks, at gas networks, it's important that these are built to have 20, 25-year lives. And you can't do that now with SDH. Not unless you buy an awful lot of old equipment and spend a lot of time with it in stores trying to repair it and maintain it. It's just not a way forwards.
And Elia, do you see a list?
Yeah, for me, for a service provider point of view, these network services would be voice, the usual suspect, voice services, those who are moving to voice over IP, of course, the legacy mobile backhaul, those service providers that still have 2G and 3G over this legacy E1s, SDH, mobile backhaul. That's one of the services you can migrate. And of course, synchronization. Synchronization used to be delivered via E1s, 2 megabit. But nowadays, with even stricter synchronization requirements, would be or designed to be in IP networks. So 1588, for example. And especially moving to 5G, it would be required to move your synchronization on an IP network.
Okay, thank you, Elia. I mean, I actually think that's a great place to leave it, because we've managed to go from TDM to 5G in one session, which is, we have to mention 5G, of course, because everybody does these days.
Help it. I don't want to, but you forced me.
So thank you, everybody, for joining us. Feel free to contact us about any further questions or dialogue you want, and I'll hand back to Lance to sum up the session. So Lance.
Thanks, David. Thanks, David. Thanks, Tony and Elia, for the presentation. And thank you all for joining. As David mentioned, yes, please do reach out to us if you have any other questions that come up that weren't answered or asked here today on the webinar. Later today, you'll get an email with a link to the replay of the session today and a copy of the slides, so be on the lookout for that. And feel free, as mentioned, to reply to that email if you do have a question. But we thank you for your time and appreciate your attendance. And we hope to hear from you soon. Take care and have a great rest of your day.
Thank you.
Thank you.